Hello sir, welcome to our presentation on system stability in state space form. So, I am Akshay Gade along with my team member Santosh Avtade, Shubham Bairat, Tejas Bharud and Krishna Gade. So, today we will explore how to state space form approaches robust and versatile framework and for analyzing the system complex. So, today we are covering the content of introduction, state space representation, syntax, MATLAB code, application, advantages, disadvantages, conclusion and references. So, we will start from introduction. So, what is system stability? System stability determines whether a system returns to its equilibrium after a disturbance. A stable system produces a bounded output for any bounded input. Why state space form? It offers a general framework for analyzing the system, linear or non-linear, time varying or time invariant. Unlike classical control, it allows modeling for internal dynamic using state variables. In this slide, stability is essential in control system. When a system is distributed by an external force, we want it to normal. That is called as stability. A bounded input should never make a system go out of control. State space form is powerful tool for analyzing such systems. It helps us model what's happening inside the system, not just what goes in and comes out. Thank you.
State space representation. This slide introduces the general form of state space module, which is mathematically representation used in control system to describe the internal states of the dynamic system. Here we have two key equations. The first one equation is state equation. This equation shows how to state of the system evolves over a time based on the current state and input. The second one is output equation. This defines how the output is generated from the states and the input. So next slide is syntax. This slide explains how to create a state space module in a MATLAB using a different syntax with the SS function. So first line is used for the basic syntax to define continuous time and space module. The second one, here we are only TS. The TS is at for the times, the sample time of a discrete time system. And the next one is existing LTL system object for additional properties. They define a static system. So we use SSD. So next one is name and value. Here we specify properties using name and value pairs. So next we are extract a specific component from LTI system. So this is essential for understanding how to implement the state space module programmatically in MATLAB. So next part will be explained by Santosh. Thank you.
Hello everyone. Today I am explaining the FCS activity of a PPT presentation on topic of state space variable, in which the general state equation of the state equation is x of t is equal to a of x of t b plus b into u of t. The output equation of y of t is equal into c x of t plus d into u of t, where the x of t is the state variable vector and u of t is the input, and when y of t is output. The system is defined. A is a system matrix, and B is the input matrix, and C is the output matrix, and D is the feed through the all direct transmission in a matrix form. And giving the example of the way in this code, in A matrix, given the value of the A is minus 1, 1.5, comma minus 2, comma 1.0 bracket complete, and B is equal to 0.5 into 0, and C is equal to 0.1, and D is equal to 0. The system is defined as a system in state space. System is a name is defined as a state space in a system. Where is the x1 and x2 are the defined variables, and output given as a x1 is equal to 1.5 and x2 is equal to minus 2 at the same value 1.5 for 1.5, and when the x2 is 1 and x2 is in second variable is 0 in matrix B, where the u1 is x1 is equal to 0.5 and x2 is remains 0, and in C matrix the y1 is x1 is equal to in y1 of C matrix is 0 and x2 is equal to 1. When there is the output of the total is u1 and y1 is equal to 0 in continuous time state space form. Continuous time of state space form. And the second is the application on the state space form is when there is a first example is the aerospace engineering. The stability of the aircraft. The stability of the aircraft in satellites in analyze to state space form models. Designing of the autopilot system in attribute into depends on the heavily stability in the analysis. Second is the robotics in automation, ensuring stable motion and control the robotics and robotics arms, drones, as well as the automatic system and autonomous which vehicles depends on these systems. Third one is the electrical and power system, the stability of the power grids and electrical drives as well as inverters. And fourth is the mechanical system, the stability of the vehicles, bridges and vehicle defined. The vibration on the system is defined from this system. The analysis of the suspension system is cars. Thank you.
Hello everyone, we are going to discuss about system stability in state space form. So I am present in advantages. First one is applicable in memo system. Application in memo system is unlike the transfer function. State space handle multiple input, multiple output system easily. Second is work in the time domain. Work is time domain in detail of the time domain analysis, capturing the initial condition, transient and the non-linear behavior more effectively. Third one is suitable for modern control. Form the basic in the modern control theory, in the including the optimal, adapting the and robotic control. Fourth one is the systematic and the scalability. Systematic and capability is easily scalable in the higher order system with the matrix based formulation ideal from the computing the tools of the MATLAB. Fifth one is the internal state analysis. Internal state analysis may provide the high insight into the internal domain of the system, not just input output behavior. So next one is disadvantage. First one is mathematically complexity. Mathematical complexity means solving the state space. The equation can be the mathematically intensive, especially for the large systems. The second one is the header interpretation for beginners. Beginners mean the physical meanings of the state variable is not always intuitive, making it the difficult for the new learn to the system behavior. Third one is the computational burden for the very large system. Calculation matrix exponential or those solving Laplace equation can become in the computationally heavy for very large system. Fourth one is the required for system model. Required for system model is the state the space analysis need for the complete and accurate internal model of the system, including ABCD matrix These can be the challenging to obtain. For fifth one is a less emphasis on input-output relation, means compared to the transfer function, detect input behavior is not immediately visible.
So conclusion, system stability is fundamental requirement for designing reliability engineering system. State space form offer a comprehensive description of system behavior by capturing both internal dynamic and external effects. State space method are flexible and apply to linear, non-linear time variant and time invariant system. Time domain analysis through state space is more realistic for practical engineering program compared to purely frequency domain method. Modern control technique like optional control, robust control, and adaptive control, computer-based tools like MATLAB and Simulink. A deep understanding of stability enable engineer not not only verify existing system but also designing controller that guarantee stability. This for a reference for this.